Okay, you should have already watched the lecture on Thomas Kuhn, because this uh, lecture on Lakatos is largely considering his account, which sort of reacts in a way to Kuhn's account. So if you haven't watched that, maybe go back and watch that. So, right, you recall, right, that Kuhn's conclusions were that theory change is not a rational process. Um, from from within different paradigms, there was no sort of way that one could argue that one was more true than the other because they each have their own standards for what makes a good theory or for what makes success. Um, so we were left in sort of a situation where it almost seemed like science, at least from theory to theory, there was nothing rational about the difference, about the change, and about there was no sort of standard by which we could judge whether science was progressing or not. Um, and that seems unsatisfying, right? So Lakatos um, reacts against this, as many of you might have as well, right? Thinking that it can't be the case that scientific theories are successful merely because of, quote, the number, faith, and vocal energy of its supporters, right? Which is sort of the picture that Kuhn starts to paint. It's just like some of the people that believed in the old paradigm die out, the younger people are into the new paradigm. So it starts to feel like politics, or right, or cheering for your favorite sports team or something like that, rather than a rational process of inquiry. So Lakatos thinks that we can provide a better account of theory change. It's going to be grounded in falsification, which you recall from Popper, right? Um, but it needs to be a little subtler than what we presented in week one. So first, Lakatos makes a distinction between dogmatic and methodological falsification. Uh, so dogmatic falsification um, believes in that there's a difference between sort of theoretical statements and observational statements, which would be sort of the logical empiricists. Right? They believe in this distinction. And we saw that Kuhn argues that there is no such distinction, that observations are theory laden. Um, so Lakatos agrees with Kuhn on this point, right? Observations, sorry, are theory laden, right? Um, uh, Lakatos puts a finer point on it and points out that since falsificationism, right, uh, views uh, the refutation of a hypothesis as a deductive argument, right? Remember, we used the modus tollens, right? You had premises and a conclusion, and the conclusion was the prediction of the theory, and then if right the prediction is false, right, then you can refute the theory by modus tollens. Um, Lakatos points out that, well, strictly speaking, arguments are a series of statements, right? So it's not that an observation refutes a hypothesis um, or a theory. Observation statement refutes a hypothesis. And since statements are in language, um, Lakatos wants to say that we get the theory ladenness from the language, right? So all languages are going to sort of have their own sort of theory ladenness. I won't get into the details of that, right? But at any rate, he agrees with Kuhn on this point, and he thinks you need to adopt an account of falsification that takes this into account. And he wants to make some further distinctions within falsification. So he distinguishes between naive and sophisticated methodological falsificationism. Okay, um, so naive falsificationism says whenever you have observation statement that conflicts with a theory, right, you have falsified, or strictly speaking, conflicts with a prediction of the theory, you have falsified the theory, right? Now we've seen that you need to be with the do problem, right? That it's not that simple. It's not entirely clear what you falsified when the prediction comes out false. You've got a whole set of assumptions, right? So sophisticated methodological falsification thinks you need a bit more than that, right? In order to refute an old theory, what you need is a new theory that does predict novel facts that conflict with the old theory, right? So it does want to make true predictions, right, that the old theory does not predict, right? So So in that sense, it is sort of the old-fashioned falsification, but it also needs to manage to make all the same accurate predictions of the old theory. So another way to look at this, the sophisticated methodological falsificationism, is this not just dealing with like, it's not treating the theory as like a single statement that can be refuted by a single observation, but rather it's a whole group of statements, and change theories. You want a new, better theory that makes all the same true predictions as the old one, plus new ones, right, that conflict with the old. Okay, so with that in the background, now Lakatos wants to explain the concept of a scientific research program, right? Um, so a research program is not unlike a paradigm, right? A Kuhnian paradigm. Um, Lakatos' scientific research program is going to be the sort of thing that when we switch programs, we do have a rational basis for it, right? Unlike Kuhn and his paradigms. So here's what a research program consists of. One, a single hard core of assumptions that researchers will always refuse to falsify. So remember the do-M problem. You have some choice, right? So you perform an experiment and your prediction turns out false. Um, you have again, what you have is a whole conjunction of statements, hypotheses. One of them must be false. It's not clear which one, and you have some amount of choice in which one you decide is false. So in your scientific research program, you're going to have to very a central core of assumptions that you will never admit are false, right? You'll always say, no, it was something else, right? Um, maybe those are the laws of logic, the laws of mathematics. Maybe if your research program is Newtonian mechanics, you're going to hold on to force equals mass times acceleration. Maybe that's in your core, right? Maybe you will be willing to give up some other things. We'll see an example of the sort of thing you might be willing to give up if you're in the Newtonian mechanics research program, right? So that's the first part. And the second part of your scientific research program is a protective belt, right? So we have Tyson with his many belts. Protective belt of auxiliary assumptions that you are willing to give up, right? If it turns out that you make a false prediction, and you need to say, well, something in my set of assumptions uh, that entailed this prediction must be false. You have a protective belt of stuff you're willing to give up. Okay? So these two parts constitute a theory in your scientific research program. So when you're changing between theories, for lack of this is guided by two different heuristics. So you got a negative heuristic, and that's scientists are going to tend to want to deflect potential falsification. So again, your theory makes a prediction, you do the experiment, it turns out to be false. You have to decide what part of your theory was wrong. So this negative heuristic is going to make them tend to want to say, oh, it's one of the part of the protective. That's the part that was wrong. Then you're also going to have a positive heuristic, which is going to be a guideline for the construction, the modification of the protective belt. So it's going to encourage you. That's where you come up with right new hypotheses that extend and change your theory. So modification of this protective belt just is theory change in sort of the less radical way. But the whole process at the end of it, we're going to see is much more unified and much more rational than so let's look at some examples. So we had Newtonian mechanics, right? We're back in 1781. This is our dominant theory that we use to predict like everything. At the time, it was like this is the grand unified sort of theory of the universe, right? So it certainly was the theory that we used to predict the motions of planets. 1781, we discovered Uranus. Moves in a way that actually is not how Newton's theory would predict it should move, right? So that's a problem, right? Does this mean Newton's theory is false? Well, people speculated that maybe it's moving funny because there's an extra gravitational force somewhere, some influence on it. like another planet nearby. And using Newton's laws, Leverrier calculated exactly sort of what sort of planet would have to be there and where, right, that would produce the weird movement that they were noticing. And sure enough, eventually they discovered Neptune, right, exact size and location pretty much that Leverrier calculated based on Newton's laws. So that was the chain. That was just an auxiliary hypothesis, right? They managed to hold on to Newton's theory, and the only part of the theory they changed was how many planets are in our solar system. They added a new planet. They didn't have to change any of Newton's basic laws, the gravitational constant, or anything like that. This was sort of the choice that you're faced with sometimes, right? You could choose to change the core of the theory or change an auxiliary hypothesis. And what they did, according to the right, using the negative heuristic, they didn't mess with the core, and they looked for changes to the auxiliary hypotheses, and then they using the protective, sorry, and using the positive heuristic, they did change their theory. They changed right the assumptions about the number of planets in the solar system. So this is a modest sort of theory change, and it saves the core. But it is, uh, according to Lakatos, right? This is good stuff, right? They did predict new things, right? Um, Kept the old predictions intact. So this is the right way for theories to evolve. But now we have another example um, where we need a more radical change, right? So Uranus was not the only planet that behaved strangely, right, in a way that was not strictly predicted by Newton's laws. This was Mercury, um, and right, the first thought was, oh well, let's use the same trick, right? There must be another planet somewhere near Mercury that's affecting it. Its gravitational pull. Um, and so they posited, well, they called it Vulcan, right, before they had actually found it. And then for years, people kept claiming they saw it, right, and then it turned out that they didn't see it. Um, and in fact, they never found it, right? And the weirdness of Mercury's orbit really never was explained until Einstein's theory of relativity, right, realized that when you're that close to the sun, the actual mass of the sun is sort of warping, warping space-time and making the light, uh, the direction of the light change. And so, like, what we're observing is actually space-time warping, right? Not Mercury moving in a funny way. Um, so here, deflecting the anomalies, right? And now anomalies, that's the same terminology as Kuhn, right? The things that can't be explained within a given theory. Here, right, you can't always deflect the protective belt. There are times when you need to change the core, and this is a case when the whole theory had to be changed. You had to give up some of the core assumptions. For example, space and time are just sort of containers that can't be sort of warped or moved. That had to be given up, right? Okay, so these two examples illustrate what Lakatos calls progressive and degenerating research programs. So a progressive research program, positive heuristic, right, predicts novel facts, and these novel facts are confirmed, right? A research program that doesn't do this, right, and is spending all of its time just deflecting potential falsifications from its core, um, this is going to be a degenerating research program. So in the case of Neptune, right? At the time, we had theoretical and empirical progress where they were predicting novel facts. They say there's going to be a planet over here, and sure enough, there it is, right? Um, and so at that time, Newtonian mechanics was still a progressive research program, right? They were still, again, predicting novel things and finding them, right? It was a living, breathing thing, which means that theories are worth keeping. However, by the time we get to Vulcan, right, the empirical progress just wasn't there. They were predicting right? Planets in order to save the core um, theory, and the planets just weren't showing up, right? Um, and all they were sort of able to do was just sort of deflect stuff and try to protect the core. And at this point, Newtonian mechanics is degenerating, right? It's time for theory change. So Lakatos thinks that these are rational conditions for theory change, right? Um, right. Well, theory change is based on, again, these heuristics, right? If you see a theory that's able to predict novel facts, um, then it's still progressive. And if it's not doing that, then it's degenerating. And so you have, again, a rational reason theories, right? If you recognize it as degenerating and not predicting anything novel. Um, so, of course, now this account relies heavily on what it means to predict a novel fact. And this is not as straightforward as you might think, right? Now, some things clearly are novel facts, like when I say you're going to find a planet right over there, and sure enough, you do. That's pretty impressive. That does feel like a theory that's really in its stride. But there's plenty of other novel facts that don't feel quite as impressive, but it's not clear what's wrong with them. So once I found Neptune, I can predict where it would appear tomorrow, and then the next day, and the next day. Um, that's a novel fact, right? It's new, but it doesn't seem very impressive, right? So what's the difference between those two? Uh, you might say, well, one of them predicts a new kind of fact, right? A new planet, where the other is just predicting sort of more of the same. Here's the position the next day. Here's the position the next day. Again, this feels like a fuzzy distinction, though. What are kinds of facts, right? And why is one a new kind and one not a new kind? Um, one thing you might say about it, and I think this came up in our discussion too, yeah, issues about scientific realism, to say that you might say it's important that the novel fact is sort of found in the theory independently of what people were trying to explain when they designed the theory. Right? We've talked in the past. We were talking last week about sort of ad hoc. Right? You could always cook up a theory that predicts the facts if you already know what the facts are. Right? I can come up with a set of premises that will predict those facts. Um, but that's not really what we want. We want something that sort of surprises us, gives us new information, that's something that indicates to us that we've latched onto something, right? We're finding new, surprising things and we're getting it right. Um, so one way you might cash that out, we were puzzling about how to cash that out in discussion, is that the novel fact wasn't the thing you were trying to explain when you designed the theory. Okay, so is Lakatos's account going to be helpful to scientists from within a theory? Remember, Kuhn said, well, when you're in a paradigm, right, you can't really see out of it. There's no rational basis for saying my paradigm is better than your paradigm because because all of your assumptions are so radically different, and even the language you're speaking is ultimately different. So does Lakatos help scientists? And he says, well, no. I think he says still from within a research program, it's going to be hard to tell whether it's progressing or degenerating. Really, it's much easier to tell right after the fact. And what we're doing is looking back on this transition between theories, and we're making what's called a rational reconstruction of this process of theory change. So it is a rational process, according to Lakatos, but when you're in it, you can't really make use of that viewpoint. Um, so it's not clear that it helps scientists, but it maybe at the very least does help us as philosophers, right? Because I think we ended the Kuhn lecture saying, well, do we even have any role here, right? If again, scientific progress of science is not necessarily a rational thing, and what philosophers do is right try to understand the logic and the rationality behind it. Then maybe we're out of a job here, and Lakatos at least gives us that back. We can, as philosophers, we can look back on theory change and make sense of it rationally from the outside.